Hello everybody, and welcome back for the second part of this tutorial on river flooding with OpenTelemac. In this video, I'm gonna show you how to project new field datas and how to modify the mesh with cats. Starting back where we stopped in the first video, we're going to add a new vector layer. This time, we are going to load the Corine land cover, which are datas listing the types of terrains that you have everywhere, like swamplands, cities, forests. In this folder, I downloaded the full Corine land cover datas for France, but I trimmed a part of them to only keep the vicinity of Yvette. This is a file that you can download in the description. Let's select it. I call it CLC IDF for Ile-de-France.jpkg. Add it. As you can see, it is displayed with only one color. We need to load the different color legends. To do this, go into Symbology, and at the bottom left there, you can see Style, Load Style, and here you can select a file. Select either the QML or SLD file, both of them contain the informations. One of them will be joined in the link in the description too. Now you can see that the datas are taking several types of colors. These colors are indicated by the legend here on the left, and it details the various types of terrains that you have locally. Let us put back our mesh on the foreground. Here it is. Now we are going to use the projection Corine land cover module of cats. Here in the CLC data files, select the CLC's data that we just loaded and save the temporary output mesh somewhere. You can then go ahead and click on Run. Now we can hide the Corine land cover datas, and we don't see any difference in the mesh that have been generated, but if you go into Properties, you'll notice it has a new bottom friction variable. That's the whole point of using Corine land cover. This allows to associate a bottom friction locally to the mesh. However, note that the typical value of bottom friction in a riverbed is about 25 meters to the power 1/3 by second. So now we are going to use the projection field module of cats in order to project this constant value of 25 on the riverbed. Let's select in area layer of projection field the refine layer to say that the projection we are going to do is only on this local area. Select a feed value of 25 and put again the right coordinate system, which is again for France 2154. You don't have to change the shift X and Y, but make sure that the input mesh is the latest mesh you generated with all of the recent informations. Finally, create again an output mesh that will contain the new informations. And you can press and run. Then you'll get an error because there is a space in the name of the variable bottom friction. So cats does not understand it. Now if you go in Properties and select Bottom Frictions, you can now see a new colored area that showcases the riverbed. If you go back on the bottom variable, there are some places where it's not very easy to distinguish the riverbed. Indeed, if you go into the Properties, Symbology, and then change the minimum and maximum of the color map, let's say keep the minimum like this and put the maximum to 80. You can see here close to the upstream boundaries of the mesh that it's almost flat. We don't really see where is the riverbed. So in this new section, I'm going to show you how we can modify the mesh datas and dig a little bit where the riverbed is. In order to do this, we are going to use a Python script that will be joined in the link in the description. This Python script will require simply a celafin.slf file, a polygon CSV file that lists all of the x and y coordinates of a polygon and the value of the shift that you want to apply. Now I'm going to show you how we can extract the x and y coordinates of the polygon refine layer, which is where we want to dig a little bit the riverbed. Click on this button and this will open the toolbox. In vector geometry, you will see a function that is native to QGIS called extract vertices. Double click on it and simply press run. This will create you a temporary layer made of all of the points of the refine layer. Now if you right click on this temporary layer and go in export and save as feature, you can select it as a format CSV and make sure that in the layer option geometry you put as XY as an option. Finally, just check if you have an X or an Y already inside the field names of this polygon, otherwise the extraction process will not work correctly. If you open the CSV you just exported, the first two columns should be the X and Y coordinates. Now, you just have to put this CSV file into my Python script. Make sure you've put the right Celafin file, the right geometry file, and as you can see the bottom shift here can be negative, and if it's negative it means we are going to dig it. So here -2 means I'm going to dig 2 meters on the riverbed. Now if you want to run this Python script, make sure you are inside the Docker container by typing the alias. You can find in the summary of the video on GitHub the full definitions of all of the alias I'm using in this video. Once you're inside the container, then go inside the folder where you have the Python scripts and you just have to call Python by typing Python3 and then the script. It will display the modified mesh. You can close this window, this is just for showing it. Now if you go in QGIS, there is a button to refresh the data that you have. These are the 2 arrows here. Click on this button. And you can see that the mesh, event bottom CLC river, has been modified. Finally, we are going to project some water close to the boundaries of the mesh, because Telemac will crash if the boundaries are completely dry. To that end, go to Add Layer, New Shapefile Layer, and then select a geometry type polygon. You can call the layer as you want. Select OK. Then go onto this layer on the left and click on this button to be able to draw. Now you can draw some small area where you want to impose some water elevation. I'm going to draw little polygons close to the upstream and downstream of the river, like so. Save the modification and toggle off editing mode, and then you can use again CAT's projection field module. This time we are going to select water depth as the variable name. Don't forget to put some comma. As a field value, we are going to impose 1 meter of water depth and select as an area layer the wet BCU or whatever you name this polygon. Then make sure you have the right coordinate system and select the right input mesh, and you can save an output mesh that will contain the newly projected water depth variable. I'm going to call it wet BC mesh. Now you can press on the run button, and again you won't see any difference, but if you go on the newly generated mesh, go into properties, you should see a water depth option. Click apply, and there you can see that water depth has indeed been correctly applied where the polygon was. Let's go back on bottom. Lastly, we are going to generate the boundary condition file. Going to create boundaries, and here in the input mesh, select the mesh that you want. In reality, it does not make any difference which mesh you're choosing, as they are all the same in terms of nodes. Now go in contour and press on the plus on the right to automatically isolate the contour nodes. Indeed, if we show again the raw mesh, you can now see that all of these little green points are the intersection of the mesh nodes and the contour. When the points are green like this means they are wall. No water is going to go through. What we are now going to do is press on the plus of boundary and select the upstream of the river, make a line that joins two green points, and then it's going to ask for Python macros. Select yes, and then you'll be able to state which type of boundary you want. For the upstream, we are going to select prescribed Q, meaning that we are going to impose a flow rate profile. Now go on the downstream part of the river, click on the green points to draw a line that will represent the liquid boundary condition. Then put yes for Python macros and select prescribed H for imposing a water elevation. Now, all there is left to do is to generate the boundary condition.cli file by selecting where you're going to generate an output mesh and running the thing. Now, if you go in the folder where there is this output mesh, you're going to see the .cli file. This is simply a text file. The most important part here are the three first integers. 222 means it's a wall, and 544 means you're going to prescribe an elevation, while 455 means you're going to prescribe a flow rate. Lastly, note that the createBoundary.slf file does not contain any information. If you load it and look at it on QGIS, this is just the mesh without any fields that we just projected so far. So you can delete it and go and look for the .slf file that contained all of the field data that we've made so far. For me, it was wet BC mesh, and you can rename it as GeoEvet to indicate that this is a geometry file. Thank you for watching this video. In the next part of this tutorial, I'm going to show you how to write a steering file of Telemac and run a first simulation. We'll finish by looking at the results on ParaView. In the meantime, feel free to subscribe, check our GitHub because there is a full description of the video here, and also a download link for everything you need to make the tutorial yourself. Goodbye!